Thank you. Yeah. So before going to the agenda, let me give you a brief introduction about myself. So myself, Mohammad Saeed. I have done B in mechanical, and then I have done specialization in HVAC. So it's masters in technology I have done. It was in 2013 I have completed my masters. So total I have 9 years of experience as a HVAC consultant. So in my career, I have designed majority of projects from industry background, some from hospital background. I guess very less from pharma also. Two, three projects I have done for pharma. My voice is low. Okay. Is that same for everyone? Habib. So maybe your audio is low, so you can just check it. Okay. If you are using a laptop, please connect a headphone to it. That will be comfortable for you. Yes. Okay. So in my career, majority of projects I have designed from industrial background, some from pharma, as I said you just now, some from oil and gas as well. It's Saudi-based projects I have done. So as a consultant, now I'm also working as a consultant. Recently, I got two to three projects approval for green building from United States Green Building Council. All projects belong to India. It's India-based projects. Recently, I have done a 50-story project which compromises of 3,800 ton of air conditioning system, and it's a USGBC, United States Green Building Council approved project. So I was the main consultant for HVAC system for that entire project. So I will be sharing you my website also, that you can get details of projects that I have done at the end of the seminar. And let me go to the agenda. Not clear. I hope it's maybe from your side. Yeah, it's clear. Please check once. So the agenda is, first I will be introducing you to HVAC system because maximum of you people belong to oil and gas and petroleum. Before going to the introduction also, let me just give some information to you. Generally, I get many questions from people from oil and gas industry, mechatronic people, or people from petroleum engineering, and people from automobile engineering, thermal engineering. These people generally ask me, sir, whether we are eligible for HVAC system or HVAC engineer. Can we apply for a HVAC post or can we join HVAC training? So the answer is very simple to them. Generally, if you see any MNC which is dealing with a HVAC, check the criteria. If you check the criteria, simply they will mention mechanical engineering or any engineering stream which has thermodynamics, heat transfer, and fluid mechanics. If you have three subjects in your engineering curriculum, then you are eligible for HVAC system. It's actually not for mechanical. If you see, in our country, we have a separate engineering also for HVAC. Means it's a graduation. So like I have done masters in HVAC. Like that, there is a graduation also, which deals with entire HVAC system. With that, plumbing and fire fitting is also included. So it's a graduation of 5 years. So generally, it's not necessary that only people who belong to mechanical engineering are only eligible for HVAC. So this is the simple answer for them. If they have these three subjects in their curriculum, then they are eligible for HVAC. Now, just let me get into the agenda. So initially, I will be providing some introduction, just what HVAC is, then how HVAC is applicable in oil and gas. Yeah. So HVAC in oil and gas, then areas in oil and gas where HVAC system is required. Actually, it's mandatory in that area. Then a small introduction to one software I will give you. This will give you some idea like how simple the design system of HVAC is. Actually, it's not difficult. Example, if you are into other field for more than 10 years, then also you can shift to HVAC because HVAC is not so difficult. So just a small introduction to make you aware, to make you confident. So a small software introduction will be given that. I will take one example and I will do the calculation of that. Then the course detail will be provided by Mr. Nikhil to you. In that, you will get information regarding the course. Okay, so now we go to the next slide. So what HVAC is? Simply providing comfort condition as per the definition. If you see standard definition of HVAC, it's providing comfort condition. So comfort conditions doesn't mean maintaining some temperature. Comfort condition, actually, it's a very defined term and very detailed term, which includes many parameters like safety, comfort, health, air purity, velocity, humidity control, and comfort is only not for human beings. There is a comfort for machinery, systems, data centers, equipments, any drug that you are storing for a pharma, any chemical that you are storing, any vegetable, fruit, or any raw material, industrial raw material, whatever you are storing. So comfort condition is for them also. People think that comfort condition means it's human comfort. No, human comfort is a different subject. We have comfort condition for many industrial objects as well. Small fact I will give you. Once when the air conditioning system was first discovered, I can say. So when first air conditioning system was discovered or invented, actually it was designed for a printing press. It was a industry. First, it was designed for industry, and for many years, people considered air conditioning only for industries. After some time, they came to know that it can be used for human comfort as well. So initially, for many years, people considered it as a application only for industries. Later on, people came to know that it can be used for comfort conditions as well. So actually, air conditioning's application is more, very more when compared to industrial area. If you see the application of residential air conditioning, it's less than 10%. 90% of our applications in industries. So this was some brief intro of the HVAC system. Now some facts I have provided here. Like as I said, many people consider give more priority to hygiene system, clean, purity of water. These people are many people are particular about that. But what about air purity? As you know, now I don't need to explain much because people have seen COVID-19 2 years back, so you have seen how dangerous it was. So air purity is actually one of the most important. Nowadays, actually, it's a more considered factor while designing the air conditioning system. So this safety is provided only by air conditioning. You can get air purity only by providing air conditioning and proper ventilation system. If you see developed cities, how polluted they are, any country you consider, maximum developed cities are polluted. How to prevent it? So air conditioning is the only solution for them. Now, let me show you some applications. Apart from oil and gas, as I said, industrial applications of oil and gas, hospital, pharma, IT industries, production and manufacturing industries, storage and food processing industries, data centers, server. These are the major sectors where air conditioning actually is mandatory. You cannot see any of these sectors without air conditioning system. All these industries has a proper, well-maintained air conditioning system. So our agenda now, our topic is for oil and gas. So as I said, you initially let me go back to the agenda. First, I will explain you the areas where in oil and gas, the areas where HVAC system is required. I can't say even required; it's mandatory. In these areas, air conditioning system is actually required. So yeah, you can see here some classification is being provided for areas. It's zone 0, zone 1. Is it changing now?
Yes, okay.
Let me again go quickly to the agenda. So initially we will have some introduction of HVAC, just the application, the full form. what HVAC is. Then I will go into HVAC in oil and gas system. In oil and gas system, where HVAC is used. Next topic, we can see areas in oil and gas where HVAC system is actually required. So this I will explain you. Then one software we will consider, small software of HVAC, just to make you aware how HVAC system is simpler when you consider from other HVAC, other mechanical topics. If you see how it is easy and how it is very simple to design, just you need some concepts and logic very clear. It's very easy. The concept of HVAC system is also very simple to understand. So just one example I have given you previously. Even if you are working in other sector for more than 10 years, also you can shift into HVAC system. And if you are working in oil and gas or petroleum, you can add this to your skill, the HVAC system, because as I said, you in industrial areas, HVAC system is more of importance when compared to residential areas. So before going to introduction, again, let me give you some information like for whom HVAC is actually suitable. So as I said, I get questions from many people from background of oil and gas, petroleum, or mechatronics. So these people generally ask me, sir, are we eligible for HVAC system? Do companies prefer us? So actually, as I said, any engineering, if they have these three topics, thermal engineering, heat transfer, and fluid mechanics. If you have these three in your curriculum, in your entire engineering, then you are eligible for HVAC system or HVAC job. Okay. So what HVAC is? So you can see the full form on the screen. It's heating, ventilation, and air conditioning system. Three things are different. Heating is different, ventilation is different. All three has different nature and different design concepts. Now, in simple language, if you see any standards, I will minimize after every slide. Okay, so you can see here what HVAC is. So it's heating, ventilation, and air conditioning. So heating is different, ventilation is different, and air conditioning. In nature, all three things are actually different. Even the design concept is also different. Some concepts are same. What air conditioning is? If you see the standard bodies, how they define, they say air conditioning is providing comfort condition. Now, what comfort condition means? It doesn't mean only temperature or maintaining humidity. Comfort condition is actually a very well defined word in air conditioning. Comfort means maintaining desired temperature with that air purity, velocity, humidity, or whatever best suitable for any equipment or any industry or any area for which we are designing the air conditioning. Like example, as I said in the earlier part also, comfort condition is not only for human. Comfort condition is also for equipment. If you see in hospitals also, we consider for MRI scan system, we consider particular temperatures. If you see in operation theater, they maintain a temperature below 20 degrees. If you see data centers also, some temperature below or nearly 20 degrees maintained. So every equipment, every machinery, even if you're storing some drug, any chemical or any fruit or vegetable, it has particular comfort condition. So the term comfort condition is the actual definition for air conditioning. If you see the application wherever air conditioning is used has a particular objective. At the end, we are going to maintain this temperature. Wherever we start a design of HVAC system, first we clear the objective. This is the comfort condition we are going to maintain at the end. So I'm going to next slide. Here you can see the extension part of the comfort condition. So one example is given here. Many people are cautious about maintaining a clean, hygienic surrounding, purity of water, but what about air purity? So how important it is? Now I don't need to go into detail of air purity, as you people are very well aware. 2 years back we have seen COVID-19. So now you can see to maintain the pure air, maximum cities if you see they are polluted now. To maintain a pure air conditioning is the only solution. Any industry, any closed areas, you see many commercial areas, residential areas, nowadays they are preferring envelope system, particularly envelope system. Envelope system is it's a closed building. So if you observe these commercial areas and also the industrial areas, the people are preferring closed system to maintain the purity of air, and this can be achieved only by giving a proper air conditioning and ventilation system. Now, how it is applicable in oil and gas industry? So some applications I have mentioned apart from oil and gas. You can see I have gone to next slide. In that I have mentioned some application. Apart from oil and gas industry, you can see hospitals, pharma, IT, production, storage industry, data center, and automobile industry. So these industries where HVAC system is actually mandatory, you have to 100% provide a proper HVAC system for operation of these industries. There are many other industries also where air conditioning is seen, but there it is not mandatory. There is option whether they can give or they can skip. But here in these specific areas, air conditioning is mandatory. Now today our agenda is air conditioning in oil and gas. So I'll be going into that sector. Now let me explain how in which areas air conditioning system is important. If you see some classifications are there in any area, in oil and gas also we have this classification. So first is hazardous areas. So hazardous areas means where possibility of some gas leakage is there, and this area is directly exposed to any sort of gas. This comes under hazardous area, zone 0. Zone 1, so you can see in normal operation where they are exposed to gas, it comes under zone 1. Zone 2, so for a short time if they are exposed, it comes under zone 2. Non-hazardous areas, these are actually not at all involved in any sort of exposure to poisonous gases. So these zones we have now. So now you see the second point. So hopefully I'll change again the slide. I'm going to second point. Yeah. So you can see here the second point. The offshore industry environment is harsh and unforgiving. So you might have heard the cases of leakage of H2S gas. Generally, this happens in oil and gas. Maximum drilling process and maximum process involved in oil and gas deals with this H2S gas. So always there is a possibility of leakage of that sector. So let me tell you, like how, let me show you one animated video which shows how HVAC will be helpful. A proper HVAC system design will be helpful to monitor this sort of leakage. And as I said, you air conditioning is not only dealing with temperature and humidity, we completely deal with comfort condition. Apart from comfort condition, in the next slide I showed you, it also deals with safety. So two things now I will explain here. In oil and gas industry, HVAC as a safety, from the safety aspect, I will show you one. Then as health wise, how it is. So two aspects I will show you. Now, let me show you one small animation which will give you some idea about how HVAC is related to safety. So, you can see here now, from safety angle I'm showing you this example. Hope this is visible to you people. Video. You can see here. So now you can see here. During the case of fire, small area shown here. Example, in case of fire, small fire started in a room, how proper ventilation system will be helpful in evacuation. So you can see the HVAC system. Here you can see, as soon as the sensor has given the signal that fire has started, you can see at the top, this is the duct system of HVAC. After getting the signal, it starts pressurization. Pressurization means the area from which evacuation is done, like from the safety zone from which people will run during the fire, when they escape during the fire, that area will be pressurized by supplying air from outside. So you can see here, this positive pressure, while supplying this pressure, this area, you can follow my cursor, these two areas will be pressurized. So it will be at positive pressure. And as you know, air flows from high pressure to low pressure. So automatically, the smoke cannot come in this area because this area has a positive pressure because of airflow. So automatically, the smoke has only one area where it can go because of negative pressure, it will go upside only. So the same thing is shown in the video. Due to high pressure, you can see this area is safe. No smoke will be there in it because of pressurization. These two, even though the door will, even though the door is open, example, again one person asking, so even though the door is open, you can see here smoke will not come because it is at high pressure. So same thing will be provided in industrial areas also. As you know, industrial areas are more prone to this sort of hazard. One more example. How positive pressure helps in evacuation. You can see here the image. So just to follow my cursor, this is the area where fire has started. Now, this area is connected to this shaft. This is open shaft for exhaust system. So as soon as the fire starts, this shaft will start suction. So what happens due to this suction, this entire area will be at negative pressure. And this area, so it's a fire exit. You can see, maybe you might have seen this in shopping malls or shopping centers. There is some fire escape area. So during the fire, this is used as a, this staircase will be used as a escape for escape purpose. So this technically is called as stairwell pressurization. So what we do is we provide suction here and blower on this top area. In this top area also we blow air onto this stairwell. So let me play this. You can see here the entire area is going from this side. You can see here. This is for positive pressurization. This opening. So the air will go from here. It's a positive pressure. And this will create negative pressure. Because of that positive and negative pressurization, you can see here. This area will be maintained at positive pressure. This area will be maintained negative pressure. When the smoke enters this shaft, it cannot go here. Even though the door from this side is open also, it cannot go this side because the negative pressure is in this shaft. And this is having positive pressure because of this opening. Even you can place a blower also here. There are two types of design. This is a natural positive pressure. Mechanical pressure also can be maintained by giving a blower here. So this is how safety during any fire hazard. Now come to the second point. Slide. So the second part is during normal operation, what will be the purpose of air conditioning? Keep aside during any hazard or any fire. What about during normal operation? So if you see in See, during normal operations in oil and gas industry, we have three types of conditions. A normal area where drilling system or normal work will be there. Second, a battery room. Third, a refuge room. So, what is the application in these three areas in air conditioning? So, if you see, first is dilution and purge system. For example, as I said, you in oil and gas industry, people are frequently exposed to H2S as maximum drilling process involved has this sort of gas. And as you know, if H2S crosses 200 ppm, this leads to death within 5 minutes, the occupants. So this is during leakage, but during normal operations also you have some sort of you will be exposed to H2S frequently. So what HVAC system can do during that normal operation? So let me show you one animation for that. Yeah. So example, consider this area. Consider this area of occupants where people are working. So here we apply a concept of dilution. Example, if some H2S gas in this area is available. So by using the concept of dilution, what I will do is continuously I will add air from outside. I will take some air from outside, I will filter it and add continuously into this room. This dilution concept will increase the air change in this room. Means frequently the air will be purified and changed because I am diluting it. Example, if the gas is also there, H2S gas, in that case also the air will be diluted because I'm adding outside air continuously. So this will lead to some dilution. You can see here. This is how I'm doing the dilution part. Almost consider that. And here is the exhaust part. Supply in and out, both and two. How it is achieved? There will be two blowers on the top. At the top, two blowers which will supply air. So this will maintain the ppm as I said you. Even if you are exposed continuously to 5 ppm of H2S also, this is also a slow killer for you, slow poison. It will act as a slow poison, even if you are exposed to 5 ppm. So what can I do? What is the solution? So dilution is the concept used here. By diluting the air, by adding the fresh air and diluting the existing air. So this will reduce the ppm. This concept is used. This concept is used for maintaining the health of the occupants. The first part I covered the safety, the next I have covered the health part. Now there is one more room. This is called as battery room. So it's very simple. In battery room also, the, the workers whoever maintaining that battery room, they will be exposed to hydrogen. The occupants of that room, whoever maintaining the battery, so they will be exposed to some hydrogen. So generally what we do is while designing the battery room system, we consider specific concept of pressure. I will not go into depth into the technicality, but just simple concept you try to understand. It's just we will maintain some pressure. That pressure, what it will do is it will remove the hydrogen from the room and it will allow the outside air, and it will not allow the outside air to come inside, and inside air will go outside automatically. So do two things at One particular point, it will allow outside air and it will prevent inside air. Second particular point, it will also remove the inside air once the outside air is added. So it will actually maintain particular balance by adding outside air and removing the hydrogen. This is the purpose of battery room. The last is temporary refuge room. These rooms will also be there during again during accidental or explosion or any toxic gas exposure. During that concept, these refuge rooms are built up. Even normal industrial area also will have this refuge room. What happens is, example, any sort of gas gets leaked. So if the person gets into this refuge room, it is considered as he's safe from the exposure of the gas, because this refuge room also has some concept of pressurization. What it will do is it will not allow outside air to come inside. Only inside air will be going outside. Even though if you open the door also, outside air cannot go inside because it has a high pressure inside. This is the concept of pressurization we maintain in this refuge room. So again, simple term I can use, it works as an isolation room. The isolation room also, inside air will be removed, but outside air cannot go inside because it is mentioned at high pressure. So this is the three areas. So let me just give you a quick revision. Like where HVAC system is used in oil and gases. First, zone 1 and zone 0 areas. So there we will use the concept of dilution. We will add the outside air. Second, battery rooms or any equipment rooms also. There we provide air conditioning, cooling also at the same time, exhaust also. That also we are providing in battery rooms. Third is temporary refrigeration. So in three areas, it's mandatory to provide air conditioning, and also a very well maintained team will be provided every time. A maintenance team that will take care of the maintenance of this all three areas where air conditioning is required. So now just I will take one small example and I will just make you aware of one design. Like as I said, in HVAC design, simple concepts are used. So many people maybe are aware about that. In air conditioning system, the major concept is removal of heat. The first step of design of air conditioning system is heat load estimation, like how much heat is to be removed. That actually we calculate. Heat load estimation. So just I will give you one example. I will take one example and I will calculate the heat load of that room. Small room I will consider in that room. I will remove it. I will calculate how to estimate heat using the software. The software is called as HAP. Like maximum companies prefer this software. I can say even 70% or more than 70% people are using have software for heat load estimation. So just to make you aware how simple it is, not entire calculation I will do in front of you. Just I will spend 5 minutes and I will show you how the user interface of this software is and how it works and how you calculate a small example. So now, share the software. You can see on the screen, this is how the first page of software will look. This software is called as HAP 4.9 is the version. HAP here stands for Hourly Analysis Program. So the design is very simple. In the design, we have to provide three information. First is weather information. Second is the space for which the air conditioning is to be designed. Third is the system. What type of system we are providing in this air conditioning? Like air conditioning has three types of system. If you see an overview briefly, it has three types of systems. In these three, which system we are providing for the present design? So let me start the project and saying, new. Hope this screen is visible to you. The first step is asking which standards is to be followed. So here is giving on options of three standards. Recently, we have latest 2019 standards also available. So just for example, I am taking this 2010 standards of ASHRAE. Here ASHRAE stands for American Society for Heating, Refrigeration and Air Conditioning. So these standards are selected. Now let me show you one drawing also for which the design I am considering. So small plan I have taken because like, since I was not aware about the audience maybe some freshers will also be there. So if I take a complicated industrial design, maybe they will not be aware about that, how to read that plan. So I have taken a small plan, which says that one side is 12 feet 10 inch, and the other side is 12 feet. Let me take this as 18. Let me take this as 13 feet, and let me take this as 18 feet and 1 to the right. So it has two sides. It has one, two, three, and four occupants. One equipment it is have television, and the orientation of this building. Let me consider this side. This side of the furniture. Let me take it as north one. So this is the north side, and we have four walls in the surrounding. Just take this as the example and then calculate the heat estimation for this same. So now software will be visible. So, which okay, yeah. So first thing you will ask is the weather property. So which type of weather I am designing the system. So as this is a software, I don't need to give all the parameters. It will take automatically from the standards. So it is following standards of ASHRAE as I said you already. So I'm underlining here. It is following ASHRAE standards so automatically. It will take from these values. So example, let me take it for consider a design for India. I'm taking one area. So let me take Mumbai here. So as soon as I select the city, you can see all parameters got changed. So I got all the values, like the maximum temperature of Hyderabad, which is sorry, Mumbai, which is here, and red ball temperature here, the daily range, the change of temperature, and this is the latitude for which the city belongs. And this is second page is for the design temperature. So it will tell you like from January to December. And the software, the name itself says it's an hourly analysis. So it is the hourly variation of the temperature in that particular city from January to December. It will tell you like what is the maximum temperature, what is the minimum. Dry bulb is normal atmospheric temperature is called as dry bulb. Next is you can see this is the hourly analysis. From night 12 to morning it is hourly profile is also provided. Now, next part is this all got will be selected automatically as soon as I selected city. From the north, as you know, the solar heat gain varies at every particular angle or every particular orientation. So here you can see from north, from northeast, from east, from southeast, from all these direction, how much heat I am coming. So that's what I have selected. All those things. So just let me again give a brief. In the first step, I have just selected the city. I have done it. Apart from that, I have done it. Only city is selected. Now let me go to the second step. In the second step, I am just providing the details of the space. Hope this is also visible to you. So the space properties I am providing. What is space property? So you can see here, see the drawing. These are the space properties. How many occupants are there? What area is exposed to sun? What equipment is providing heat? So whatever heat I am coming from the occupants or from the envelope of the building, from the exposed surface of the building, whatever heat I am getting, that the software will calculate. For that, it needs the information, whatever equipments or whatever parameters inside the room or from the outside, adding heat to the particular area. So from this, I will take the input data. Input data like means this wall area, window area, occupancy, equipment, what type of lighting I am providing, all data I will take from this drawing. So as you know, this whatever drawing you get or whatever plan of any industry or any residential area, whatever you get, the person who prepares the plan, the architect of that plan, that particular drawing, he will give you all the input data. Obviously, because um, until unless you get this data, you cannot assume it. So all these parameters actually this will vary from place to place. So that data should be provided. So step by step is you can see here. First is asking the name of that particular area for which we are designing. So I can name it whatever it is. room, it is any industry, whatever it is. Just give a name. Then you can see it is asking the area. What is the area of that room? So I roughly put like it is 18 by 13 or 18 by 10. So area will be 180 square feet. Then take the height of that particular 10. Next is the building weight. This is required because you need to know the conductivity, how much heat is conducting. So this we will get data from the structure whatever design. Here also you have given some idea with the building is low weight, so we can select light. The building is medium. Next, he is asking outside air ventilation. How much fresh air, how much ventilation is required for that? Simply scroll down and select what sort of area you are designing for. Any industry, a lot of options are there. Industry, meeting room, office room, lobby, public assembly. So many options are given. Any of these you can select. So I will select normal, multi-use assembly. Or as soon as I select this, here automatically calculated how much air is required, and the software also has provided you from where it got the value, which is from Ashley book 62. With this particular book for ventilation design, from there we got this information. Next, step by step, it will ask like how much heat you are getting from the electrical lighting. So, in the whatever watts of light you have provided, you can give it here. So, it's like a company. Watt, 300 watt, whatever it is. 100 watts, so it is fine. He's asking for schedule. What time the light is used, so I'm keeping it as default one. I'm not schedule. Example, that industry works for 24 hours. So you cannot give a schedule for that type of industry. Lighting is completed. So just the information that I have to give here is what is the capacity of light. Type of light also is asking, but simply you have this information from the drawing. So just look at it. Next, equipment. What sort of equipment is there? So example, you have whatever the equipment is. For us, how much heat coming from that equipment, that is important. So if you know the watt, so from the watt, the software will automatically calculate how much heat will come. So just to provide here the wattage of that equipment. Example, that equipment is of 1500 watts. So just put the wattage. Immediately the software is going to calculate how much heat will come. Next is occupancy. As you know, human body is offering example. That how much heat and how much heat. It will ask how many occupants are there in the room. So, 5 occupants. So, from that 5, how much it will come? The activity, what they are doing. If we are doing some heavy work, like in industry, you can say residential ones, I can say. Again, as I said, this software data. This value software is also taken for standards. Next, is after information about the wall. So, at what orientation wall is it? For example, at north one wall is there. An example at west another wall. That's not taking two. North wall I'm taking as 180 feet. South wall I'm taking as 180 feet. This information again. How many windows it has? So, now we will ask what type of wall we are using. So I'm taking one default. This is the type of wall. Next is asking about the roof. What is the area of the roof? I've selected the direction of the roof, which is horizontal to the sun. So it is H. Taking the roof assembly also as default. Because type of roof and type of wall actually to be defined here. Because the software need to know how much heat the conduction value of that particular wall or particular roof, whatever it is, the software need to calculate. So that information if I provide it, what is the thickness of the wall, what is the if I provide this information, software is going to calculate. For that reason, he's asking the type of wall, type of roof, type of window, whatever you will do. Calculate how much is the kind of next infiltration. How much air changes per hour and one for maximum type of design for comfort. The industrial, it is prescribed by astrophysics. Percent condition is 2%, 5%. That are given. The next, I have selected the type of floor I am using, partitions, whatever partitions I have in this room. That I have selected and I am doing the area of the partition. What is space data that I have selected. So this is the input information I have given. Enter all these apps I am doing the input values. So nothing to be calculated. Just whatever information I am getting from the client. So the software is going to calculate automatically. Now, as an engineer, we also should have the knowledge like how the software is going. So for that manual calculation is required. That we will see during our full course because it is not possible to explain the manual calculation in an hour. So it takes nearly 3 to 4 hours for me to explain how manual calculation is done. It requires arithmetic calculations and also some time. So in the total course, we will be seeing how manual calculation is also done. So, okay. Now for this software, I have just given the input. Now, third party system. Which type of system I'm going to select? Just we will ask the type of system I'm going to. I'm giving the name of default. The type of AC I'm giving, so I'm giving normal type of AC. As maximum people are not from HVAC background, so I will not be going into complex examples. Just I'm taking this basically everyone has seen so that example. Yeah. So now he's asking type whatever component that are present in the AC. That also will put the board. The zone for which I'm designing the AC, the zone I have iron. And we are also asking the schedule for AC, like at what time I'm going to AC. So just I'm keeping these also default. 24 hours are going. So I'll go for default. So in system properties, I have done nothing. Just I have selected the type of AC. Then I have added the zone. Just I have taken default. Default value automatically solved. Is this the total input information? No. Now I will give a command here to calculate the load. Now, the input information the software has. Now the software will calculate as per the input values whatever we have given. It will calculate the load. It will come. So this is the input information. As per the input information, whatever we have provided, the area, the city, the type of wall, the software has got a load of 1.1 ton of refrigeration. This is the load the software has got as per our input values. Rest of the input values and everything is again given in detail for our process information. This is the result that we got. This is the ton of refrigeration. At the bottom, you can see this is the airflow that will go. EU, whatever it is. Ventilation, all the software has done automatically. So, for this calculation, as you can observe, it's very simple. You only need to just know how to use this software, you can easily get the result. But again, as you see, in the industrial or in commercial, it will not be so simple. The architecture will match. Every time there will be some specific issue with that drawing. So we need to have some analysis also. Directly simply by the result provided the software, we cannot decide the capacity of the equipment. Sometimes we change it. Some logical decisions and some research is also required. So I'm not saying that the It's very simple, like everyone can do. You should have some knowledge of thermal engineering, you should have some knowledge of heat transfer. With this software, this knowledge is applied. And using these two things, you will come to a conclusion and select the equipment at the end after doing this calculation. This is the first step of air conditioning HVAC design. So in this step, you will get two results: the airflow to be provided and the capacity for air conditioning provided. So okay, so now let me quickly brief you whatever we have gone through from the beginning. So initially, we started with the introduction. Just I gave you the explanation of what comfort system is, then the application of air conditioning system. Then I went to use of air conditioning system in oil and gas. Some areas I explained you where air conditioning is mandatory in oil and gas. Then I took one example to just make you aware about the software that are going to be used in air conditioning. So I have selected HVAC software, which is widely used in the world. Every country I have seen they are using HVAC software. Maximum I can say 70% I can say they are using HVAC software. So I have taken one example of HVAC software and the same thing if you see if you join the total 1 week program, you will see these things in detail with technical calculation. So hand over